week's NFV SDN Reality Check, we will talk about the ONOS project on the recent launch of its Blackbird SDN platform and speak with Chris Rice at AT&T Labs on the carrier software plans.
Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Thanks for joining us on this week's NFV SDN Reality Check. I'm your host, Dan Meyer, Editor-in-Chief of RCR Wireless News. Recently, ON Lab, always mess those up, launched its ONOS project in last December. The initial launch targeted service providers with a scalable SDN control plane. Earlier this month, the ONOS project brought out its Blackbird SDN platform, furthering its efforts in the SDN place. Today, we are joined by Prajakta Joshi, who is the Director of Product at ON Lab, to talk a bit about its latest software release. Prajakta, thanks for joining us today. We appreciate it.
Good morning, Dan, and it's wonderful to be here.
Thank you, appreciate it. So, well, maybe give us, I guess, a little background on perhaps ON Lab initially, and then maybe a little bit on the ONOS project as well.
Sure. So ON Lab essentially is a non-profit organization, and it was founded by essentially the folks from Stanford and Berkeley. Mm-hmm. And the whole idea was that, in fact, SDN has its roots at Stanford. And the whole idea was to build this organization that would create platforms that help SDN get adopted by the community. So essentially, these were open source platforms. And that's how the organization came about in 2012. So some of the other projects that came from ON Lab include MiniNet, which almost everybody in the SDN community uses, OpenVertex, which is more of a network hypervisor, and there's another platform called OpenCloud, which is more of a cloud operating system and a sort of set of services that go with it. Now, in 2012, the service providers, if you know, SDN is already there in data centers, mm-hmm. and taking it to service providers has been much harder. And so essentially in 2012, ON Lab talked to a number of service providers, and they said, we want to bring SDN into our networks. But in order to do that, we need a platform that has performance, that has high availability, that has scale, and then, that is able to support a diversity of services and devices. Mm-hmm. So it was with this goal, essentially, that ON Lab started the ONOS project in 2012. Mm-hmm. And, if you've looked at, I think the documentation is from 1975. So it's the Gall's law, which says, a good system that works today most likely evolved from a simple system that worked before. Uh-huh. So essentially, ONOS went through the same route. So there were two prototyping efforts in 2012 and 2013. The first prototype essentially was to show that a platform like this was feasible. Mm-hmm. And the second was to show that you can actually get performance out of a platform like that. So when I say a platform like that, it means essentially building an SDN controller, but very different from what existed then. And this was essentially to build it using the concepts from companies like Google and Facebook, mm-hmm. which you sort of scale out. So when you want higher performance, you essentially instantiate everything on simple commodity hardware, but then you add another instance to scale up. So that was sort of the premise behind ONOS. So we wanted to keep it cheap, but we wanted to keep it high performance, highly available, and so on. So most of 2012 and 2013 went in these prototyping efforts. Uh-huh. And then beginning of 2014, maybe about around February or March of 2014, there was immense interest from service providers and vendors to create a partnership around this project. So that is when ONOS project partnership was born. And this comprised of all stakeholders. So essentially service providers, vendors, mm-hmm. ON Lab, which was essentially the non-profit neutral entity, as well as a number of folks from research and academia. And so starting March 2014 to December 2014 was when the current ONOS took shape. And we sort of vetted out the architecture. We made architectural enhancements. We also supported 4 interesting use cases when we went open source. Mm-hmm. And so, with all of this in place over maybe 7 or 8 months, ONOS was open sourced by this community of service providers and vendors and ON Lab on December 5th, 2014. So that's the journey of ONOS so far.
Got it. Yeah, and obviously, like you said, too, this is something that's really been driven, it seems like, by the carrier community. It seems like the telecom operators are really been at the kind of pushing this move towards virtualization. And obviously, SDN is a big part of that. It seems like that's been a big driver for you guys, and obviously for ON Lab and the ONOS project too.
Correct. So it's really interesting. I think it started with AT&T's Domain 2.0 program. essentially, I mean, that was really radical for a company that's AT&T size. And they've actually been, I mean, they came up with a phenomenal plan. They've been delivering on it. And they do realize that, given that they're spending $20 billion on CapEx every year, there is only so much you can grow your network. At some point of time, you have to grow the right parts of your network, but make the rest of your network more efficient. You also need to bring in components that give you the agility you need to sort of create new services, monetize services, cut down costs, including CapEx and OpEx.
Yeah.
So SDN is actually a perfect fit for service providers. The problem is, how do you get SDN into service provider networks? Because service provider networks by themselves are not simple and monolithic, let's say like data centers, right?
Yeah.
Data centers mostly are under the control of one organization, but it's different with service providers. So for instance, they have their access networks, which could be wired or wireless. They have their central offices, they have their metro pops, they have their core, right? But one thing that does not change across all these networks is the need for a high performance, a highly available, reliable SDN control plane. And the second thing that you need is, when you're putting a system like this in your network, you want ease of service creation. You also want a good migration path. So bringing all these components together into an SDN control plane is a pretty challenging task. And that's essentially the mission behind ONOS. So I think that's what really makes it attractive to service providers.
Yeah, that's a good point, because it does seem like, again, like in the legacy data center or IT centers, it does seem like virtualization is a very easy, well, not so easy, but a simpler process. It seems like it's more integrated into those systems. Where with the telecom operators network, like you're saying, I mean, there's so many pieces involved, so many legacy systems, various vendors involved, billing systems. And I mean, it's just such a complex creature that has been built over the past 20, 30 years, that trying to virtualize and trying to unify these things under one platform, I mean, that seems like a huge challenge. Obviously, for you guys working on this, I'm sure that was kind of, I'm guessing, a big impetus for this move towards open source and bringing it all together, or at least trying to bring it all together.
Correct. Yeah. And I think the good thing is, in order to bring SDN into a service provider network, what you need is some prerequisites such as performance, high availability, and scale, right? Yeah. And then once you have your, let's say, northbound and southbound side figured out, you don't need to do a forklift upgrade, really. What you can do essentially is bring in SDN in pieces into your network. And that's pretty much what our service provider partners are doing. So, it could be simple things such as, let's say, building a small SDN island and using an SDN IP application on top of ONOS to peer with the rest of your internet, right? So, or the rest of your network. So what that means is, you're not really doing a forklift upgrade. You're introducing SDN in a really tiny part of your network. And then slowly, as you get comfortable with the learnings from this deployment, you sort of extend the footprint of that small deployment. So that's one of the things that we observe service providers doing. The other things that we see them doing are, for essentially, they're taking parts of their network and doing small trials, but using the same set of platforms that they would use when they actually deployed in the real networks. So that's another thing we see with ONOS, and that's sort of been a key tenet of ONOS, that don't build a platform that can simply go into lab, but build a platform that you can enhance and essentially move all the way from lab to a trial to an actual deployment. So that's the route we are taking.
Sure, got it. And obviously, I know the ONOS project itself launched, like you said, back in December. I'm guessing it's only been a few months so far, but it seems like, I'm guessing traction's been pretty good. I know you had a lot of carrier support, a lot of partners involved with the initial launch. I'm guessing so far it's been pretty smooth?
Actually, it's been phenomenal. Let me put it that way. So when we went open source in December, we were too busy to actually focus on what traction. It was just about putting good code out there, and also not only putting a platform, because at the end of the day, a platform, if you talk to a service provider about the platform, they don't really care about the platform. What they care about is the sort of things that enables you to do, right? So the platform is simply an enabler. So when we open sourced ONOS on December 5th, 2014, we also demonstrated 4 use cases along with the platform. And these ranged from a migration strategy, which was our SDN IP, to an NFV style network function as a service. So it's a more scalable, more intuitive form of NFV. And we also demonstrated multi-layer SDN control with our packet optical use case. So essentially, the goal was not only to demonstrate the platform and its capabilities, but also what it can enable. Beyond that, the developer traction. So, when you think of community, I sort of think of the following things. One is, we are building this platform for service providers. are we able to garner enough traction with them? So AT&T and NTT have been supporters right from the beginning.
Yep.
We added a new partner, SK Telecom, in February. And you'll soon hear a new announcement about China Unicom. So for sure, and you're probably the first one to hear.
I was going to say, that's a nice team there.
Because it happened this morning. But yeah, so I think that's the biggest thing. First of all, the people that you're building your platform for, do they believe in the potential? Do they believe they can take it into deployment, right? So that's the first part. Mm-hmm. Similarly, the vendors themselves have a very important part to play. So as you know, ONOS has 7 vendors in the partnership, right from Cisco, Ciena, Ericsson, Fujitsu, Huawei, Intel, and NEC. And the numbers, again, will continue to grow. So they bring in their expertise. They also are committed to delivering real SDN value. So, and they also sit across the tables from service providers with ONOS project. So that sort of gives them like a face-to-face understanding of what the service providers need as well. So we have been getting tremendous traction. In fact, Cisco joined in February again. Yeah. So then the last part and the most important part is the community itself, right? Are you able to attract the developers to come and contribute to ONOS? And I have to say, although we've been out in the open source for maybe a few months, the IPv6 project that we have is completely driven by community. The NetConf project is driven by a small company called Happiest Minds in India. Yep. So a lot of the parts of the project are already being driven by the community. And if you see, for instance, the mailing list, we've had tremendous feedback on what they like about it. And we're also making sure we listen to parts that we haven't perfected, and then the community sort of helps us enhance the platform to take it all the way to service provider networks.
Makes sense. Okay. All right. A very collaborative effort, it sounds like there too. Now, obviously, earlier this month, you guys launched the Blackbird platform as well. I guess provide, a quick synopsis there of what that is and what that brings to the product as well. Maybe how it builds on the initial ONOS launch.
Sure. So before I get there, let me tell you an interesting nugget about ONOS releases. Okay. So if you notice the ONOS logo, which I have right here, let me see.
Oh, wait, there it is.
Okay, it's a bird.
I need to get one of those. Okay, go ahead.
Yeah, I'll send you one over. The ONOS logo, we purposely chose the bird. It sort of symbolizes openness and freedom. So in some sense, naming the releases was a no-brainer, and decided to go with birds in alphabetical order. So it was incredibly difficult to find a release name from A, so we went with Avocet. And our next release, so Avocet was the open source release in December 5th, 2014. Yep. And our next release is Blackbird, which released about a month back. Yep. And if you know about Blackbird, so there are different, of course, it's a bird too, but there's a legendary jet called Blackbird. Yep. And jet was known for performance and speed. And that's sort of what we tried to do with the ONOS release. So the ONOS release for Blackbird essentially focuses on performance, high availability, and scalability. Now, when I say this, it's interesting because depending on who you talk to, people may have a different interpretation of performance, right? And that boils down to the basic question. If you look at performance numbers for any SDN controller or control plane platform today, they focus on something called C-bench numbers. Yep. And in some sense, C-bench numbers are the least indicative of the performance. Simply, they measure the IO loop performance, but they don't measure the number of other things that are really critical for a controller. So, we started with the first premise. What is it that really defines the SDN controller performance? And the second thing is, how would you quantify it? How would you measure it? And then the third thing is, we took the ONOS Blackbird release, we measured the numbers, we published all numbers, good and okay as well, because we know, there is always room for improvement and enhancements. And we sort of put out two white papers on Blackbird, and we wanted the industry as well, so all other SDN controllers, to publish similar numbers, because at the end of the day, if you are a service provider or an end user, you want to be able to compare apples to apples and then pick the one that best fits your need. So that is sort of the theme of the Blackbird release.
Got it. Okay. And now, obviously, this release, again, it's still pretty new in the market right now. Like you said, about a month ago. I'm guessing we'll see some uptake on that here pretty soon. But as you said, too, you guys are going with the bird theme. So I'm guessing the next one will be a seabird.
The next one actually is cardinal. That's already finalized. We are still looking for a name for D. So everybody has ideas.
We'll start a contest here. We can name the next release for ONOS there with the Ds. Yes, yes. We can do that as well. So
that's That's true. So, the interesting thing that I wanted to point about, especially the Blackbird release, is a couple of things, right?
Sure.
First thing was we wanted to define what performance means. And, we almost wanted to think of an SDN control plane like a black box, right?
Mm-hmm.
So let's say you brought this SDN control plane into your network. What would you evaluate, right? So the first thing is at the bottom or in the southbound of your SDN control plane, you have your switches and you have your network, right?
Mm-hmm.
If something was to go wrong with your switches, or let's say one of the links went down, you definitely want the SDN control plane to detect it as fast as possible, because in some ways that's the way it can either reroute around that failure or at least flag it or log it, right?
Mm-hmm.
So that we thought was an important metric. The second one is how much raw horsepower do you have to sort of program your data plane, right? So in case of OpenFlow, for instance, how many flow rules can you program? So that's almost like your flow operations per second. It's like a throughput number, right?
Mm-hmm.
So once you've thought of the southbound, then you start thinking of the northbound, right? For those who are familiar with ONOS, I'm sure you've heard of the application intent framework. In fact, intents is now the buzzword in the SDN industry today, but we sort of embarked on this intents and providing a clear-cut northbound abstractions right from the get-go when we started working on ONOS. And what the northbound intent framework essentially allows you to do is, you go to the SDN control plane and you say, give me, let's say, path from data center 1 to data center 2,
Mm-hmm.
and optimize it for cost. You don't care what your network looks like. You don't worry about what your network looks like. The control plane figures out how to instantiate this path, right? Now, all this is well and good, but what this also means is that your northbound has to be highly performant as well.
Mm-hmm.
So if you're running 100 applications on different instances of ONOS, they're going to push in a lot of requests, and then you have to be able to service those. So essentially, this northbound throughput is another metric that we deem really important for the performance of the control plane. And the last thing is when your application said install something, or give me this path, how long does it really take to instantiate all the way from that instance to it going all the way to being programmed in your data plane or your switches, right? So that is the latency that is, again, very important. So in effect, what we said was, let's start with these 4 or 5 metrics, which is essentially your topology change latency, your flow installation throughput, your northbound latency, which is not only installing and withdrawing what the application wants, but also in case of failures, rerouting against those failures as well. And then, so once we had the performance there, the second thing that Blackbird focused on was scale out. So scale, if you've looked at Google or Facebook or Amazon, the word
Never heard of it.
Yeah, scale out is very popular, right? So the whole idea is, so ONOS internally is a distributed controller, but logically centralized. What that means is it's a cluster, and you have different instances, but they together behave as one ONOS, right? What that also means, though, is as you need more horsepower, let's say you added more switches or you have more applications, you can simply add another instance in the cluster and scale up your controller.
Got it. Okay.
You don't need to buy a more expensive box. You don't need to do anything. All you need to do is just introduce commodity hardware in there, or throw hardware at the simple commodity hardware at the problem, and then scale up your control plane, right? So the important thing, though, is although there are other distributed systems that are out there, there is none that has demonstrated the scale out effect. So it's possible that if you don't architect the system well, adding another instance could cause your performance to deteriorate, not improve, right?
Yeah.
So we demonstrated that with ONOS, that as you add instances, you almost scale up linearly. So that was another important thing. And then the last thing is, of course, what everybody wants, which is high availability and reliability. So what you want is uninterrupted operation in the wake of failures. And that's, again, something we demonstrated with ONOS. So whether an instance dies, another takes over. If something happens to the application, the one running on another instance takes over, and so on. So the different nuances to high availability. But we sort of encapsulated all of these 3 things, which is your performance, scale out, high availability. And that's what we call the carrier grade quotient of SDN control planes. So we published all these metrics. We've also published methodologies on how to measure these metrics. And then we've also published the corresponding numbers for ONOS in the Blackbird release.
Got it. Yeah. Okay. Well, obviously, a very, very intensive release there. And then I guess we can look forward to the next release, Cardinal, here coming up, I'm guessing, pretty soon as well. And once that comes out, hopefully we can touch base again and get some insight on that. But again, it sounds like you guys are doing a lot of work there. Obviously, still a pretty new project, but you guys seem very busy. And obviously, it's a market and a segment that is growing rapidly. I know, talking with carriers and other analysts and stuff, that this is a segment that is growing. Everybody's pretty excited about it. A lot of news coming on it. So I'm sure you guys are staying very busy out there on the project. So again, hey, Prajakta, we definitely appreciate the time today and the insight on this. And like I said, hopefully once the next one comes out with Cardinal, we can maybe touch base again on that subject too. So again, we appreciate the time today.
Thank you so much, Dan. It's my pleasure to be here. Thank you, everyone.
Great. All right, sounds good. Well, great. Well, like as Prajakta had mentioned there, obviously AT&T was as a big member of this virtualization movement by telecom operators. Again, like was mentioned, the domain project that they came out with a couple years ago has definitely gained a lot of insight, a lot of traction. And recently had a chance to talk with Chris Rice, who's a VP at AT&T Labs, about the company's software focus, beginning with its latest software release into Apache Incubator status.
A bigger really effort around open source and the contributions that open source are making, general in the technology industry, but certainly within telecom. Specifically, what we did in this case is with a couple like-minded companies and a lot of, quite frankly, software that we had written, we went in and we had put it on GitHub earlier. This is a policy engine, access control policy engine. So it's something that you'll use within systems that allow or disallow based on, resources, time of day, role, any of those kind of things. And it's built to something called XACML, Extensible Access Control Markup Language. It's done to the latest specification, which is 3.0, and it had not really been available in open source at that level before that. And so while we had it on github.com, we also found a couple like-minded companies that went together with us, and we put it in Apache Incubator status. And we have Incubator status now. And as we garner more support, we hope to get it to full project status.
Got it. Okay. Now, obviously, like you said, the software is an open source type of platform, which, from my coverage, at least of the telecom side of things, that's a pretty big push for a lot of companies. I know a lot of organizations have popped up looking at open source as a key to what they're doing, whether it's OpenStack or different companies like that. It does seem like that's a really big part of this. And it seems like from what you guys are doing, obviously open source is a pretty important part of this for you guys as well.
Yeah, clearly it is. And you had mentioned OpenStack. There are others, ODL, some work we're doing with the folks in Berkeley on Lab, ONOS. And so, for our standpoint, and I think, again, this is part of a bigger technology push for open source. If you just look at the, go all the way back to Linux and the contribution that Linux has made to the technology community, you're going to see more and more of that. And I think what's happening is you're starting to see it filter into probably what was considered more specialty technology areas like telecom. And we have our own unique needs associated with that. But I believe that, as we garner more support within the community, and that's one of the reasons you put things back into open source. You say, why do you do this? It's like what you want to do is get broader support rather than what's within your company, get people to fill gaps, do other technologies that are associated with it, and cause it to grow and be something we can all build on and benefit from.
Rice also provided some insight into the importance and limitations of automation and managing telecom networks, as well as how AT&T views the importance of the latest software push garnering Apache project status.
What you want it to do is you want to have automation handle all the ones that make sense for it to handle, and then really have your people spend the time on the exceptions where it really makes sense. You don't want them spending their time on mundane tasks that could more easily be handled through automation. And to be honest with you, when you run something at our scale, that's a lot of what you do day to day. So the more we can automate that, the better off we are.
Yeah, that makes sense. Now, I guess how important will it be for this software to kind of get that the Apache project status? I mean, obviously, you guys are working through the incubator process now. Is that going to be is that like kind of an end goal for this? Do you think to really get to that next step, or I'm guessing you guys are pretty confident it will get to that step. But how important will that be for this process?
I think it'll be important. I mean, there is a standard out there already now for XACML, so it's not like we need that to have the standard created. But what we want to do is have this be what I'll call the reference implementation of that standard through Apache. And you're right. I mean, you learn a lot as you start doing this, and that's one of the reasons why we've tried a bunch of different directions, if you will, for how we might want to do open source. Just contributions, part of initiatives, work jointly with a small company, and this one kind of, in a couple of times, do it from scratch. Mm-hmm. And in this case, when we went through and did it from scratch and then went to that next step of making it part of the Apache Incubator, we said we also have to have, it's not just us, no matter how great we think this is, we have to find like-minded companies who are going to go do this with us, that are want to work with us. And so we found 2 or 3 or 4 that are going to be part of the initial incubation, but part of that other work is building that community. That's I don't want to say as much as, but that's a large part of creating this and making it happen and making that developer experience as seamless as possible and all those other things you got to go through that, quite frankly, when we worked with that small company in Silicon Valley, Cass, we learned some of that, right? And so we're a lot smarter.
From on the interview, including insight into AT&T's growing software focus, how that focus is altering the company's operations, and challenges ahead for the continued software development in the telecom space, you can check out the RCR TV site. Well, that'll do it for this week's NFV SDN Reality Check. Again, I'm your host, Dan Meyer. Thanks for joining us this week. And I also want to thank our guest, Prajakta Joshi from the ON Lab, and also Chris Rice from AT&T. Also, if you have any suggestions for the show, please feel free to let me know. You can reach me at dmeyer@rcrwireless.com, which is DMEYER@rcrwireless.com. Or you can follow me on Twitter at Meyer_Dan, which is, again, Meyer, MEYER_Dan. Well, again, thanks again for watching this week, and we'll see you again next week.
NFV SDN Reality Check with Dan Meyer is a production of RCR TV. To suggest show topics or to reach Dan, you can find him on email, dmeyer@rcrwireless.com, and on Twitter at Meyer_Dan. For more Dan, news on NFV SDN and everything wireless, find your way over to rcrwireless.com.